Okay, we're now in the next topic of 4.3, which deals with conditional probability. So the way you want to envision conditional probability is that you're computing the probability after some specific event has occurred. So this event is having an impact on that probability. So let's take a look at an example. So it says two cards are drawn from a deck. Compute the probability that the second card is a jack, given that the first was a jack. Okay. So let's just mention here as well that the cards are selected without replacement. So that just ensures that we have a conditional probability that in which the probability is being modified. Okay, so the formula that we will use is this is our conditional probability formula. So it's the probability that B occurs given that A occurs first. And we have a formula. We just calculate the probability that both events occur and divide by the probability that A, which is your condition, occurs. So let's just kind of go through our notation. B is the event that we are finding the probability of. A is the condition. Probability of A and B is a chance that both of those events occur. And probability of A is a chance that A occurs. And then just some of the key words you're looking for would be given that. So whenever you see those two words in a problem involving probabilities, you're dealing with conditional probabilities. And that given that corresponds to this straight line that we see between B and A. The condition always follows the line. So let's work out this problem that we posed at the beginning of this section. So we're saying, what's the chance that the second card we select is a jack, given that the first is a jack? Well, we calculate the probability that both are jacks, divided by the probability that the first card is a jack. So first card is a jack, 4 out of 52. That card is removed. Second card is a jack, is 3 out of 51. And then the probability that the first card in general is a jack, 4 out of 52. Well, these values divide each other out, so you'll be left with 3 out of 51, which reduces to 1 out of 17. Now, you don't always have to rely on the formula. Sometimes we can just use common sense. So let's think about this. Let's just imagine that we've removed one jack from the deck. How many cards are in the deck now? 51. And how many of them are jacks? 3. So you could easily just rapidly come up with the answer as 3 out of 51 without resorting to the formula, which reduces to 1 out of 17. All right, so that's the concept. We're going to have everyone try some of these problems. I'm going to go ahead and work out the first example, and I'll work out another example below. So this first example says the following. Andrea is a very good student. The probability that she studies and passes her math test is 17 out of 24. If the probability that she just studies is 15 out of 16, find the probability that she will pass her math test given that she studied for it. So she has studied, and we'll say for the test. All right, so let's set this up. So kind of the key words again, once again, it would be see, I just want to, so you see the two keywords that are given that? That's letting us know we're dealing with a conditional probability. So we need to calculate the probability that she does both. She studies and passes the test. Well, that's given. That's 17 out of 20. So that's our numerator. So that's the probability of her doing both, studying and passing the test. And then we're going to divide this by the chance that she studies, which is 15 out of 16. So let's go ahead and divide these two numbers, and let's see what we're able to compute and we should end up with 17 out of 4,800. Well, what we can do also is we can just represent this as a decimal, so it's 0.0035. And let me just go ahead and verify that really quick. I just want to make sure that I have it correct. Yeah, that is correct. So that's our probability. In this case, since the fraction gets really large in the numerator, we'll just leave it as a decimal. Now this is using our formula. There are other problems where we could avoid using the formula. So let's take a look at example 4b. So 4b says the following: a box contains 5 blue marbles, 6 red marbles. So let's write this out. So 5 blue marbles, 6 red marbles, and 4 white marbles. So altogether there's 14 marbles. Okay. All right, so let's answer the question. It's saying, so this is just using straight notation. Okay, so that notation is telling us what's the chance that we select the red marble given that the marble that we've selected is not blue, right? So we're selecting one marble. Well, all we have to do is, first of all, how many marbles are not blue? Well, we exclude blue, so we have 6 red and 4 white. So that means altogether we have 10 marbles. And then we ask ourselves, of those 10 marbles, which are red? Well, 6 are red out of the 10. And then we can just simplify that, divide out the 2, so you have 3 out of 5 as the answer. So in this example, we didn't have to resort to the formula. We just used common sense. So sometimes you could just rely simply on common sense. Other times you can apply the formula, but sometimes the formula gets too complicated and people get bogged down with the notation. So try to use as much common sense as possible. We can also use conditional probabilities for the contingency table. So we have some problems for you to try, but I want to work out 2 examples just to kind of demonstrate how we would calculate these probabilities. So I'm going to switch over to Excel. So we have the same data set, but I think I have a couple of different examples here just to kind of demonstrate how we work with conditional probabilities and a contingency table. Well, the first example says, what's the chance that a person's a female given that the person has blue eyes? So the data set is gender and eye color. Once again, you could apply the formula, but as I mentioned before, it gets a little complicated. So what we're going to do is we focus on the condition. The condition is blue, meaning blue eyes. So let's just highlight that column. So our condition is saying that the person has to have blue eyes. We don't care about people that have any other eye color, but those that have blue eyes. And we know that there's 24 of them. Of those 24, how many are female? Well, 10. So our probability would be 10 out of 24. And then that's going to reduce to 5/12 as the answer. Okay, now let's take a look at another example. This is also a conditional probability. It's saying that the person has black eyes given that the person is female. So you notice female is now the condition. So if female is now the condition, we don't highlight a column, we have to highlight a row. So we have to highlight the row with all the females because that is our condition. So we don't care about the males in this problem, only the females. How many females are there? Well, there's 99. How many of them have black eyes? 28. So it's 28 out of 99, and that's going to be the answer. And so just remember, when you're working with conditional probabilities, you always just highlight the row or column that contains the condition and then find the cell that has the numerator. or the value that, or the event you're looking for. There's a couple of other problems for you to try. Work these out. And if another note just to be aware of, like this first example here, brown eyes, since there's no condition, that means you're going to use the entire sample space. Only when you see the little lines, which are represented by the two words, given that, that's when you focus on your condition. Thank you very much.